In a significant week for NASA and the broader scientific community, multiple breakthroughs and collaborative efforts are being reported showcasing advancements in space exploration technology and research. From rocket propulsion testing to the innovative use of 3D printing in space missions, these developments underscore a commitment to pushing the boundaries of our understanding of the universe. On March 18 to 19, NASA's Stennis Space Center in Mississippi welcomed over 100 members of the 57th Rocket Test Group. This gathering aimed to foster collaboration among rocket test facility operators and was facilitated by a partnership with the Mississippi Enterprise for Technology. The attendees toured the facilities, including the Fred Haise test stand where the RS-25 engines are tested for NASA's Artemis missions, and the Thad Cochran test stand, which is set to test future exploration stages for those missions. The Rocket Test Group, established in response to congressional demands for interagency collaboration, serves as a platform for operators to share insights, reduce testing costs, and solve critical problems in rocket propulsion testing. This initiative allows us to learn from one another and improve our capabilities, said a representative from NASA Stennis, highlighting the importance of networking and knowledge sharing in advancing rocket technology. In a parallel development, NASA's SPHEREx space telescope has successfully captured its first images since its launch on March 11. The telescope, designed to map millions of galaxies, turned on its detectors and began sending back images that confirm its systems are operational. Our spacecraft has opened its eyes on the universe, stated Olivier Dora, project scientist at Caltech and NASA's Jet Propulsion Laboratory. The images, which reveal tens of thousands of stars and galaxies, are just the beginning of SPHEREx's mission to gather data across infrared wavelengths that will deepen our understanding of the cosmos. SPHEREx is set to conduct routine science operations later this month, taking approximately 600 exposures daily. These efforts will contribute to a comprehensive mapping of the sky, aiming to document over 450 million galaxies and 100 million stars in the Milky Way. The telescope's unique ability to take a broader view compared to its predecessors such as Hubble and James Webb promises to provide invaluable data that may unlock secrets about the universe's origins and the physics governing its evolution. Further advancing the exploration of new technologies, researchers at the FAMU-FSU College of Engineering have received a $5 million grant from NASA to study advanced 3D printing techniques for space missions. Led by Professor Subramanian Ramakrishnan, the project aims to develop innovative materials and manufacturing technologies that could revolutionize how astronauts create necessary tools and components in space. Imagine being able to print sensors, radiation shields, or even functional tissues as the mission progresses, Ramakrishnan explained, emphasizing the potential for on-demand manufacturing to enhance mission sustainability. The research team is exploring the use of lunar and Martian soil to create special inks for 3D printing, a technique that could significantly reduce reliance on materials transported from Earth. Additionally, they are utilizing electrohydrodynamic printing methods to develop flexible electronic sensors, showcasing a fusion of materials science and engineering that could have far-reaching implications beyond space exploration. As NASA continues to explore the effects of strong magnetic fields on star formation through the Webb telescope, the organization remains at the forefront of scientific discovery and innovation. These concerted efforts not only enhance our knowledge of the universe but also pave the way for future explorations and technologies that may one day allow humanity to thrive beyond our home planet. With these developments, the future of space exploration looks promising. As NASA's initiatives evolve, the integration of advanced technologies and collaborative research will undoubtedly lead to new discoveries that reshape our understanding of the universe and our place within it. In a recent showcase of excellence, NASA's Spaceflight Awareness Program honored several employees from the Stennis Space Center during a ceremony held on March 10 in Orlando, Florida. The awards celebrated the outstanding contributions of these individuals to the agency's human spaceflight initiatives, particularly in support of the Artemis program, which aims to return humans to the moon and beyond. Among the honorees was Melissa Wagner, a contract specialist who played a crucial role in identifying potential risks related to propulsion tests for NASA's Artemis campaign. Her proactive approach led to successful mitigation strategies that contributed significantly to the program's progress. Wagner, along with fellow honoree Simone Wilson, a public affairs specialist, exemplified the spirit of teamwork and dedication that NASA values. Wilson was recognized for her effective communication efforts in promoting NASA Stennis activities, ensuring that the public remains informed about the agency's missions and initiatives. Other recipients included Timothy Miller, a senior drafter who, although unable to attend the ceremony, was honored for his support in flight systems integration and cost reduction through innovative modeling techniques. Similarly, Madison Monti received recognition for her contributions to the security processes at Stennis, ensuring a secure and efficient badging office. The awards were presented by notable figures including NASA astronaut Randy Bresnik, who has extensive experience in space missions and now oversees the development and testing of systems for future Artemis missions. Bresnik highlighted the importance of these awards, stating that they reflect the hard work and commitment of NASA employees who go above and beyond their normal duties to ensure the success of human spaceflight programs. In addition to receiving their awards, the honorees enjoyed a tour of NASA's Kennedy Space Center, where they observed the SpaceX Dragon spacecraft named Endurance. This spacecraft is set to carry astronauts to the International Space Station (ISS) as part of NASA's Commercial Crew Program, further underscoring the collaborative efforts between NASA and commercial partners in advancing space exploration. As the space industry continues to evolve, initiatives like the Spaceflight Awareness Program serve to reinforce the importance of quality and safety in human spaceflight. The dedication demonstrated by these employees not only contributes to the success of current missions but also lays the groundwork for future explorations beyond Earth. Looking ahead, as NASA gears up for its ambitious Artemis missions and beyond, the contributions of individuals like Wagner, Wilson, Miller, and Monti will be pivotal in navigating the challenges of space exploration. The agency's commitment to recognizing and rewarding exceptional efforts ensures that the spirit of innovation and teamwork will drive future successes in the quest for knowledge beyond our planet. In a touching moment that captured the hearts of many, NASA astronaut Sunita Williams has shared a heartwarming video of her reunion with her beloved dogs after an extended stay aboard the International Space Station (ISS). After spending over 9 months in space, specifically 264 days, Williams returned to Earth on March 18, 2025, alongside fellow astronaut Barry Butch Wilmore. The emotional footage, which Williams posted on social media, features her exuberant Labradors expressing their joy at her return, a scene that many viewers have hailed as the best homecoming ever. The reunion began after Williams underwent medical tests post-mission, ultimately receiving clearance to return to her home in Needham, Massachusetts. The video showcases a jubilant atmosphere as Williams leans down to greet her dogs, asking them in a playful tone, "You know who I am? You know?" The two Labradors, a yellow lab and a black lab, respond with wagging tails and playful antics, including one dog attempting to shower her with kisses while the other proudly displayed a stick. The joy of the moment resonated with viewers, sparking a wave of admiration and well wishes on social media, including posts from NASA and SpaceX founder Elon Musk. Commentators expressed their delight, with one saying, "Welcome home, Suni. Now, did you hug the dogs or the hubby first?" Others remarked on the pure tail-wagging love the dogs displayed, emphasizing the emotional bond between humans and their pets. The video serves as a reminder of the profound connections that sustain astronauts during their missions and the comfort that home can bring after long periods away. The backdrop of this reunion is significant. Williams and Wilmore's prolonged stay at the ISS was not initially planned. Technical challenges extended their mission far beyond the anticipated 8 days, leading to a total of 286 days in orbit. For Wilmore, the experience was not only a test of physical endurance but also a spiritual journey. A devout Christian, he relied heavily on his faith throughout the extended mission. "My God-given family and my church family provided him with strength," he noted as he led devotionals and shared moments of worship with fellow astronauts. As both astronauts readjust to life on Earth, they face a period of rehabilitation, 45 days for Wilmore, an essential step in reacclimating to gravity after such an extended time in microgravity. NASA has indicated it will compensate both astronauts for their time in orbit, albeit at a modest rate of $5 a day. When asked about potential additional compensation promised by former President Donald Trump, Wilmore humorously remarked, "Praise the Lord. I like a little extra cash." The emotional and physical challenges faced by astronauts during long-duration spaceflights continue to spark interest and discussion. Williams' joyful reunion with her dogs underscores the personal sacrifices made by those who venture into space and the powerful connections that await them upon their return. As space exploration continues to evolve, the stories of astronauts like Williams and Wilmore will remind us not only of the scientific achievements but also of the human experiences that define these extraordinary journeys. Looking ahead, as NASA and private space enterprises like SpaceX expand their missions and capabilities, the public will undoubtedly remain captivated by the stories of astronauts returning home, their journeys, and the emotional reunions that followed. In an era where the boundaries of scientific exploration are continually expanding, citizen scientists are stepping into the spotlight. Utilizing NASA's Open Science Data Repository (OSDR) to probe the mysteries of life in the cosmos. This collaboration between professional researchers and enthusiastic volunteers reflects a growing trend in science that democratizes knowledge and promotes global participation in understanding our universe. The Open Science Data Repository Analysis Working Groups (AWGs) are at the forefront of this initiative, inviting individuals from diverse backgrounds to join their quest to uncover how life can endure and even thrive in the harsh conditions of deep space. These groups are focusing on critical topics such as the impact of radiation, the effects of microgravity on human and plant health, and the behavioral changes of microbes in orbit. "We are encouraging everyone to engage with us," a NASA representative stated. "This is not just a scientific endeavor, it's a collective journey to explore one of humanity's most significant challenges." Currently, 9 AWGs meet monthly, tackling specific areas of research while collaborating through an online platform known as the AWG Forum Space. Here, members can connect with peers, engage in discussions, and contribute to over 20 active projects. With access to a wealth of data covering physiology, molecular biology, and bioimaging, participants can explore more than 500 studies and utilize an omics multi-study visualization portal, among other resources. The initiative not only fosters engagement but also empowers participants to propose new projects, from data analysis to establishing data standards. This inclusivity allows for a broader range of insights and innovations, vital for enhancing our understanding of extraterrestrial life. In a related realm of exploration, researchers at the FAMU-FSU College of Engineering are pioneering new frontiers in 3D printing technology for space applications. Backed by a substantial $5 million grant from NASA. This initiative aims to develop advanced composite materials and manufacturing technologies that could revolutionize how astronauts fabricate essential tools and structures in space. Professor Subramanian Ramakrishnan emphasizes the transformative potential of this technology. Imagine printing sensors, radiation shields, or even functional tissues during a mission, adapting to challenges as they arise. The project involves collaboration across 7 institutions and focuses on integrating advanced materials, including innovative 2D materials known as M-zines, into specialized inks for 3D printing. This capability aligns with NASA's vision for in-space manufacturing (ISM), which aims to enable astronauts to produce necessary components on demand, thereby reducing reliance on Earth-based supplies and enhancing mission sustainability. Moreover, the implications of this research extend beyond space exploration. The novel sensors and materials developed could have significant applications in biomedicine and materials science, potentially addressing pressing health challenges back on Earth. In another significant advancement, NASA researchers have recently shed light on the multicellular behavior of a unique group of bacteria known as multicellular magnetotactic bacteria (MMB). This study reveals that these bacteria not only navigate using the Earth's magnetic field but also exhibit obligate multicellularity, meaning their survival depends on living in groups. This fascinating behavior offers insights into the evolution of life on Earth and highlights the complex interactions within biological systems. The findings underscore the importance of studying such organisms as they can provide clues about the mechanisms underlying multicellularity, a pivotal step in the evolution of life that has led to the diverse ecosystems we see today. As the researchers noted, understanding these unique bacteria could help us unravel the evolutionary strategies that have shaped life on our planet. As citizen scientists delve into extraterrestrial mysteries and researchers push the boundaries of material science, the future of space exploration appears vibrant and full of possibilities. With collaborative efforts expanding the horizons of knowledge, humanity stands at the brink of understanding not just how life can exist in the harshness of space but also how we might sustain it for generations to come. The journey into the cosmos continues, driven by innovation, collaboration, and an unwavering curiosity about the universe. Recent scientific inquiries have opened a portal to astonishing possibilities about our universe, hinting at the profound and unconventional idea that we might be living inside a black hole. A groundbreaking study conducted by researchers at Kansas State University utilizing data from NASA's James Webb Space Telescope has revealed compelling evidence regarding the rotational behavior of galaxies that challenges existing cosmological theories. The study examined 263 galaxies and discovered that a substantial majority were rotating in the same direction, contradicting the long-held belief that the cosmos is isotropic, meaning that galaxy rotation should be evenly distributed between clockwise and anti-clockwise directions. Lior Shamir, an associate professor of computer science at Kansas State University, elaborated on the implications of this finding, stating, "It is not clear what causes this to happen, but there are two primary possible explanations. One explanation is that the universe was born rotating, which aligns with black hole cosmology, theorizing that our entire universe exists within the confines of a black hole. Black hole cosmology posits that the Milky Way, along with every other observable galaxy, is contained within a black hole that originated from a much larger universe. This theory calls into question fundamental cosmological models, particularly the notion that the Big Bang marked the universe's inception. Moreover, it raises the intriguing possibility that black holes might serve as gateways to alternate universes, suggesting a multiverse structure. While this study provides a tantalizing glimpse into the nature of our universe, Shamir cautioned that more research is necessary to substantiate these claims fully. He also suggested an alternative explanation for the observed rotational patterns, attributing them to the Milky Way's own rotational velocity affecting the measurements. If that is indeed the case, we will need to recalibrate our distance measurements for the deep universe, Shamir noted, emphasizing that such recalibration could help solve other unresolved cosmological enigmas, including discrepancies in the universe's expansion rates. In a separate but equally ambitious realm of space exploration, discussions surrounding a potential manned mission to Mars have reignited interest and debate. Former President Donald Trump, during a recent congressional address, pledged to lead humanity in a quest to plant the American flag on Mars, expressing confidence in private sector partnerships, particularly with Elon Musk's SpaceX. "I said to Elon, is that doable?" Trump recounted, "Absolutely. He loves rockets, that guy, man." The intersection of governmental ambition and private enterprise has stirred excitement, but experts warn of significant hurdles ahead. Musk envisions a self-sustaining city on Mars, arguing that establishing a multiplanetary civilization is crucial for the long-term survival of humanity. Yet former astronauts and experts consistently express skepticism regarding the feasibility of achieving such ambitious timelines, with Derek Pitts, chief astronomer at Philadelphia's Franklin Institute, characterizing Musk's proposed timelines as overzealous. The challenges of a Mars mission are daunting, ranging from advanced spacesuit technology needed to protect astronauts from harmful radiation to the vast distances involved. A round-trip journey to Mars could take approximately 3 years, raising questions about human endurance in isolated and confined environments. Furthermore, Pitts highlighted the complexities of ensuring sustainability for astronauts during extended missions, stating, "If you start to look at the practical things, it's going to take quite a bit of time to actually pull it off." As NASA continues to prioritize lunar exploration through its Artemis program, the agency remains cautious yet optimistic about the future of Mars exploration. NASA's current Moon-to-Mars exploration approach calls for using missions on and around the Moon to prepare for future human missions to Mars, a spokesperson commented. Nevertheless, the timeline for landing astronauts on Mars appears to be pushed further into the future, with experts estimating that a realistic timeframe could extend to the 2040s. Ultimately, while the notion of living inside a black hole and the ambition of sending humans to Mars present compelling narratives, both concepts underscore the need for continued research, technological advancement, and international collaboration. As we stand on the brink of these cosmic frontiers, it is clear that the journey ahead will not only redefine our understanding of the universe but also challenge the limits of human exploration. The coming years may reveal whether we are indeed inhabitants of a black hole or pioneers of Mars, each scenario shaping the course of humanity's quest for knowledge and survival in the cosmos. In a pivotal moment for NASA's lunar exploration ambitions. The recent congressional hearings have shed light on the evolving landscape of the agency's Commercial Lunar Payload Services (CLPS) program. As discussions unfold, the future of lunar missions, particularly the volatiles investigating polar exploration rover Viper, hangs in the balance, prompting significant implications for both NASA and the private aerospace sector. At the forefront of these discussions are executives from key companies involved in lunar landings who are advocating for a more robust and responsive approach from NASA regarding its procurement strategies. During an April 1 hearing of the House Science Committee's Space Subcommittee, representatives from Firefly Aerospace, Astrobotic, and Intuitive Machines argued for substantial changes to the existing CLPS framework, which has thus far facilitated the delivery of payloads to the Moon through commercial partnerships. NASA's CLPS model was the catalyst to our success, stated Jason Kim, CEO of Firefly Aerospace, whose Blue Ghost 1 lander successfully touched down on lunar soil just a month prior. Kim emphasized the need for stable multi-year funding commitments to ensure a consistent cadence of missions, aiming for 2 to 3 per year. He suggested that such commitments would not only enhance efficiency but also bolster the supply chain necessary for the burgeoning lunar economy. Echoing Kim's sentiments, John Thornton, CEO of Astrobotic, called for a strategic re-evaluation of the CLPS program in anticipation of its next iteration, dubbed CLPS 2.0. He proposed that NASA consider block buys of landers from companies already engaged in CLPS missions, which he believes could yield significant cost savings and operational efficiencies. This will enable U.S. lander providers to buy in bulk from their U.S. supply chains and save CLPS money, Thornton noted. However, the hearing was not without controversy, particularly regarding NASA's decision to cancel the Viper mission, which was initially set to utilize Astrobotic's Griffin lander for its lunar deployment. This cancellation has sparked concern among scientists and lawmakers alike, with Brett DeNevy, a principal staff scientist at the Johns Hopkins University Applied Physics Laboratory, voicing skepticism about the strategy of seeking private funding for the rover's transport. "We should not expect Viper science to happen by hoping that someone will offer to fly and operate it on their own dime," DeNevy cautioned, highlighting the risk of falling behind in lunar exploration, especially as international competitors like China ramp up their efforts. In defense of the decision, Nikki Fox, NASA's Associate Administrator for Science, stated that the agency lacked the budgetary resources to support Viper without jeopardizing other CLPS missions. "We did not have the budget to be able to support Viper moving forward," she asserted, indicating that maintaining Viper would have necessitated the delay or cancellation of several other lunar missions. As the discussions continue, the implications of the Viper cancellation and the broader CLPS strategy will undoubtedly reverberate throughout the aerospace industry. The potential for collaborations with other government entities such as national security agencies was also raised, suggesting that expanding the CLPS portfolio could lead to enhanced efficiency and innovation through shared investments.
Ultimately, as NASA navigates these complex challenges, the future of lunar exploration hangs in the balance.
The agency's ability to adapt its strategies and funding mechanisms in response to both industry needs and congressional oversight will be critical in maintaining its leadership in lunar exploration. As stakeholders eagerly await the development of CLPS 2.0 and the fate of the Viper mission,
it is clear that the next steps will shape not only NASA's lunar ambitions but also the trajectory of commercial space exploration in the coming years.